Okay, so looking at example 1 on your orange handout, it says we want to graph y less than or equal to negative x squared plus 2x plus 3. So we're going to follow the 3 steps. Step 1, the inequality symbol is less than or equal to, so make the parabola blank. What are we going to put there? Solid. Okay, so here's how you do this. You change it to an equal sign, and you graph the parabola. Now I need to mention that we already covered graphing parabolas. If you struggle today with trying to graph it, that's a problem. That's a huge problem. And you need to come in at math study table to get help with that. I'm not going to reteach graphing parabolas because we've already done that. That means you need remediation and you need to get that fixed. Okay, so it's not appropriate for you to ask me in class how to graph a parabola. So the vertex, we do x equals negative b over 2a. So this is negative 2 over 2 times negative 1. That's negative 2 over negative 2, which is 1. Now I need to find the corresponding y value. So I go to the equation and I have a negative out front, 1 squared plus 2 times 1 plus 3. Okay, we've already done this before. Notice that negative is not inside a parenthesis with the x. Only the x is getting squared and there's a negative in front. So y is negative 1 plus 2 plus 3. So y is 4. So the vertex is 1, 4. Now once you have the vertex, what do you do to graph your parabola? You have to make a table or a t-chart. Good job. So we're going to make our chart with 5 rows. In this case, we actually don't need the axis of symmetry for what we're doing, but it's a good idea. Now 0 is a very friendly number. So if I plug in that x is 0, I get 3, and then I am going to use symmetry though. You're onto something there. And then you can either choose 3 or negative 1. I think if I could avoid the negative, I'm going to. So I'm going to plug in negative positive 3 squared plus 2 times 3 plus 3. That's negative 9 plus 6 plus 3. Hey, isn't that nice? That's 0. Alright, so now what we're going to do is we're going to plot a solid parabola. Here's negative 1, 0, 0, 3, 1, 4, 2, 3, 3, 0. We said it's solid. And it opens down, and shouldn't it? Because the a was negative from ax squared plus bx plus c. Now the next step is test a point inside the parabola. So let's do 0, 0. If you can use 0, 0, you want to try that because 0 is so nice to work with. I'm getting 0 less than or equal to negative 0 squared plus 2 times 0 plus 3. 0 is less than or equal to 3, that's true, so you shade inside. So what this means is that there are infinitely many solutions here. This means not just 0, 0, but 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2. I could do 0, -1, 0, -2, 0, -3. Like, do you understand that this means all of the shaded points are solutions? And there's too many to even count, okay? All right, now, set the orange paper to the side for a moment. We're going to come back to it, and I need you to find your 4.9 notes. And we're going to do example 1 there for practice. It says graph a quadratic inequality in 2 variables. So these are the same steps that we had in the orange foldable. You graph it, make it solid or dashed, test a point inside the parabola. If it's true, shade inside the parabola. If it's false, you shade outside the parabola. Okay, so let's look at example 1 together. So we're going to change this to an equal sign. And this one's dashed. So you're going to graph the parabola. So I start with my vertex, x equals -b over 2a. So that's -4 over 2 times -1. So x equals -4 over -2, so x is 2. Then I need to find the corresponding y value, so I plug it into the equation. So I'm getting y equals -4 plus 8 plus 2, so y is 6. Then you're going to make a table of values with the vertex in the middle.
If there's fractions, will you use our calculator?
Yes, but this one doesn't have any.
No.
Okay. Yes, if you do get one, and we're going to look at one here in just a moment, you do get a fraction, and we'll use the calculator. All right, so if I plug in 0, I get 2. And if I plug in 1, okay, so remember we said this one's dashed, so be very careful with that. So we've got a dashed parabola, and then we need to do a test point. I can use 0, 0 because that's inside, and I'm getting zeros greater than 2. Well, 0 isn't greater than 2. That's false. So I don't shade inside. I'm actually going to shade outside. Like that. Okay? Alright, what I would like you to do is I'm going to try to help you out here, is if you look at the worksheet I gave you for tonight's homework, I would like us to do one more problem as practice, and we'll get one of your homework problems done. I want you to look at number 8 with me. Okay, look at number 8. On the homework tonight, it says graph y greater than or equal to x squared minus 2. Alright, so this one's solid, and you make it y equals x squared minus 2. to do the vertex, what do you know about B? It's 0, so there's really no work to do. You don't even want to make it negative 0 over 2 times negative 1. If there is no B, the x is 0. So then y is 0 squared minus 2. So the vertex is 0, negative 2. Alright, so if I do 1 squared minus 2, that's negative 1, and you'll use symmetry to fill in your table. And then if I do x is 2, 4 minus 2 is 2. Now remember, this one is solid. Okay, you guys get it? Making sense? Okay, I want you to now look at the handout I gave you that had multiple choice. Do you see that? And I'm sorry I'm making you toggle between so many different things here. But I want you to take a moment here, and there are 5 graphs. There's one on the back. And there are 5 inequalities. I want you to take a moment, and I want you to try to match the inequality with its graph. And just where it says equation, put A, B, C, D, or E. Now suppose you're a student who's struggling. What would be a suggestion to something to be looking for? Megan?
The negative x squared so you can see which way, if the graph is going down.
Awesome. Okay. The first thing you should notice is letter A and letter E have parabolas that are opening down. That's only 3 and 4, right? And then guess what you could do? Okay, now they're both greater than, less than, so they're both dashed. Another option would be looking for solid and dashed. But look at letter A's equation. If I let x be 0, what's y? Negative 6. So out of 3 and 4, which one has a point going through 0, negative 6? Number 3. So 3 is A, and that makes 4E. You see how easy that was to sort of match them up? Now, in the remaining ones, B, C, and D, 2 of them are solid and one's dashed. So what does that make number 1? B, okay, that's the only one that was dashed. Now, do the same thing I did on that first one in letter D. Let's say I look at D. If I plug in x is 0, I get 4. That has to be which one then? 2, right? 2 has to be D, and then what does that force 5 to be? C. Okay, so do you see how you can use some process of elimination there? Alright, so now you're done with that matching one. Now let's go back to the orange paper, and I want you to look at example 2 with me. Now we're going to take it up a notch. We have just learned how to graph a quadratic inequality, and now we're going to graph a system of quadratic inequalities. What if we have 2 of them together? So we're on our orange paper, and what you're going to do is you're going to graph each one and shade it. And where you see both shadings, that's where the solution is. Okay? What?
Is this another color?
You can use colors, but you don't have to, because I'll show you when we're done. You're just going to darken one spot, okay? So let's look at the first one. We actually just did this one, but I think it was solid. So this one's dashed. So we're going to start off with the vertex. Remember, there's no b, so x is 0, y is -2. Okay, so we already did our table, right? Do you guys remember? On number 8. Now this one's dashed. And my test point, 0, 0, is 0 greater than -2? Yes. And what I would recommend when you're doing the system, just very lightly shade. Okay, very lightly shade it. All right, does everybody have the first one on there? Now we're going to do the second one. This one's going to be solid. And so my vertex, here's where we're going to get that yucky fraction. I'm getting -3 over 2 times -1. So that's 3 over -2, or -3/2. Okay? Now, I'm not going to expect you to do fractions and decimals by hand. So let me show you what I want you to do with this, okay? Take out your graphing calculators, and I'm going to show you a feature I may or may not have shown you before. If I did, it was a while ago, so I'm going to do it as if we've never seen it. So go to your Y screen, and I want you to enter the equation -x² minus 3x plus 4. Whoops. I need to go turn my stat plots off from what I was doing in pre-calc. So let me get out of there. So again, it's in my Y screen, -x² minus 3x plus 4. Everybody have it entered? Okay, now do Zoom 6 in case you were messing with your window. And then here's what I want to show you that I may or may not have shown you before. If you press trace, you can actually type in any number you want. I'm going to type in -3 divided by 2 and press enter. And it's going to give me 6.25. So let's make our little XY table. And then watch what we can do. That's -1.5. So let's say I go to -1 and then 0. And then let's go -2, -3. And then watch. On my graph, just type in -1. -1 is 6. 0 is 4. I can do -2, -3. Okay? So you can graph it, but you have to press trace, and then you can type in any number you want. And that's if your vertex or the problems are going to spit out decimals, okay? So let's plot this. I've got 0, 4. Oops, so I got to increase my graph here. -1, 6. Now be careful, -3/2 is only half a unit. Now this one's solid. And then we can do 0, 0. I'm getting 0 less than or equal to 4, which is true. And then do you see it's this in between space right here. And then this is where you want to darken it. If I can't tell on your paper that it's clearly the in between, then I can't give you full credit for it. So do you see that it would have been inside this parabola, and then where they're overlapping is where you see both colors or two shades. Okay? All right, questions? Yeah.
My calculator,
Yeah. Oh, you just have to do second window and put it back on auto. There you go. That'll work. Alright, now let's go back to the 4.9 notes, and let's do another one of these in example 2. Okay? So you're done with your orange paper. Don't throw it out though. It's got all the steps that you need how to do it. It's really neat. Alright, so here we go. Example 2. And then, so today we graphed quadratic inequalities and a system of quadratic inequalities. Tomorrow we're going to solve quadratic inequalities. We're going to move to solving them. Right now we're just graphing them. So with the first one, this one's solid. Then you change it to an equal sign. And then let's find the vertex. Well, x is 0 because there's no b, and then y is 4. So I'm going to plug in 1. Now be careful with your order of operations. That's a negative out front. Okay, my test point, I'm trying to do it real light so that when you're done, your final region, you'll be able to tell what it is. Alright, then let's look at the second quadratic inequality. It's solid. Now, I want to show you a second option. When I look at this second one, it's jumping out at me that factors. The first one, no, but the second one, yes. can tell it's going to factor, I'm going to show you, for those of you that can sort of follow it, you can use the intercept method. Do you guys remember that when we were graphing quadratics? My x-intercepts then are 3, 0 and -1, 0. Then I don't have to make a table. I still need to find my vertex, but then I can use the two x-intercepts to graph it. So my vertex is -2 over 2 times 1. Then the y value would be 1 squared minus 2 minus 3. So I have a 3, 0, a -1, 0, and 1, -4. It's solid and it's opening up. Now, if that's blowing your mind and you're like, what? Then don't do the x-intercepts. But that one just really jumped out at me as that's going to factor. And if it factors, I know the x-intercepts. Okay? And then let's test point it. 0, 0 is 0 greater than or equal to -3. Yes, so it's inside my blue one, but it also has to be inside the red one. So it's just this region in between those two.